right, folks, I wanted to do another example, which will actually showcase using both integration by parts and a U-sub in the same question. So this is combining two ideas into one integral. It's kind of fun to see those ideas come together. So here's an integral that looks pretty interesting. So it's the integral of e to the root x dx. So I go through my checklist, right? The tools in my toolbox. I don't see any algebra that will help me here. U sub, I mean, there's not an immediate U sub that makes sense to me. Parts, also not immediate parts that make sense to me. So I mean, this is not so easy to see what we're supposed to do. I guess because I see a composition, right? I see e to the square root of x, right? I see a composition of things. Maybe U sub feels useful here. So why don't I let U be the square root of x? I mean, that's a reasonable first choice. That way I'll have e to the u, which is a nice function. So if I let u be root x, then du would be 1 over 2 root x dx. Or solving for my little dx, I get 2 root x du. Okay. Let's plug all this in, see what we get. So I'm going to get the integral, that's all equals then, the integral of e to the u, right, because that's root x. And then dx I'm replacing with the expression 2 root x du, okay. Now, initially, this looks problematic because I have an extra root x in there, but, look, root x is none other than u, so I can replace root x with u and turn all the x's into u's again. So this is actually pretty good. So I have 2u du. So now I'll pull out the 2 from the integral and simplify a little bit. I got u e to the u du. And now when I look at this, well, this looks like a product of two things. And integration by parts feels like a pretty useful technique again. So from here, why don't I use integration by parts to try to solve this integral? Now the problem is I've used u already, so I don't want to do u and dv. Let me call my integration by parts formula, but with w and dv maybe instead. Okay. So what should I make w? Well, my typical choice is to let w be the thing which will become simpler when I differentiate, and in this case, u. When I differentiate u, it'll become 1, and so that's simpler. So I'll let w be u, and dv be everything else. So e to the u du. Okay, so I need to calculate my dw. Well, that's going to be 1 du. I need to calculate my v. Well, that's the antiderivative of my e to the u function, which is just e to the u. Okay, no problems. So what do I get? 2. I'll leave the 2 out in front. Let me put a big bracket here so I don't forget to distribute later. So I'm going to do wv, okay, instead of uv, but it's going to be u e to the u minus integral v dw. So that's e to the u times 1 du. So that's a pretty nice expression. That's u e to the u minus, well, the antiderivative of e to the u is just itself. Wonderful. Plus a constant. And now let me distribute that 2. Let me also plug back in. Initially, my problem was stated in terms of x's, so u is root x. Let me plug all that back in here. I'm going to get an expression that looks like 2 root x e to the root x minus 2 e to the root x plus, now you could write 2c if you want, but c is just a constant, so 2 times a constant, still another constant. I'll just call it c to make it look a little bit nicer instead of calling it 2c. Okay, cool. A little bit more complicated, but really fun example here. All right, hopefully this is helpful. I think you'll find it helpful for some of the homework questions, and if you have questions, come let me know.